Okay, here's another Alex problem on specific heat capacity. It says calculate the energy required to heat 838.0 grams of graphite from 10 degrees C to 24.8 degrees C. And then it gives us the specific heat capacity of graphite under those conditions. It's a pretty simple one. I think you guys probably didn't even need to do this one. But let's just do it. The change in energy is equal to specific heat capacity times the mass times the change in temperature. We're given specific heat capacity, we're given the mass, and we got to figure out that change in temperature. Change in temperature is final minus the initial. The final is 24.8 degrees C. The initial is 10.0 degrees C. And so if I do that math, I have 14.8 degrees C as my delta T. I can then plug that in. Delta E equals the specific heat capacity, which is 0.710 joule per gram per degree Kelvin, times the mass, which is 838.0 grams, times the change in temperature, which is 14.8 degrees C. So if I do that math, then I get an answer of 8805.704 joules. Okay, we know that that doesn't look right because of sig figs. Governing me here, I have 3 sig figs there, I have 4. Okay, so 3 sig figs is going to be here. That will then give me 8810 joules. That would be an appropriate answer. Sometimes it's better to convert these into sig figs, and so that'd be 8, or to scientific notation, excuse me. 8.81 times 10 to the third joules would be the answer. This is the equivalent. Alright, specific heat capacities can be quite simple.